Hello, Keith Rucker here at VintageMachinery.org. Guys, today we are still moving forward and making progress here on our Stoker engine restoration. This is going to be going in a mainline steam locomotive. This is the Stoker engine that is used to power the mechanical stoker that augers the coal that's in the tender of the locomotive into the firebox on the boiler of the locomotive. So this is an auxiliary unit that basically mechanically shovels that coal. As these locomotives got bigger and bigger over time, it became increasingly difficult for the firemen to be able to shovel enough coal to keep that locomotive running. So they came up with a mechanical stoker that would do that using the steam from the locomotive to power this little steam engine again, which powered that auger to keep the coal going into the firebox. Today, what we're going to do is try to get the Babbitt poured in the crossheads on this locomotive Stoker engine, and so that we can start working on trying to get this thing assembled and put back together. I talked about before when I got this engine to restore, the little slides that these crossheads move back and forth in were extremely pitted from where it had been sitting outside in the weather for many years, basically in neglect. And we had to machine some surfaces, some area out of those to get down to good clean metal. And now the little Babbitt block that slides in that is undersized. So we're going to melt that Babbitt out and re-pour it to actually fit into the cross slide that we've machined so that everything should work right. Now to do this properly, we needed to get it aligned, everything exactly right. So I've taken the time and made a little fixture here to hold the crosshead to position it right where it needs to be. The purpose of this crosshead is back here in the back. We have a crankshaft. That crankshaft has a connecting rod that goes to the crosshead. The connecting rod, of course, is rocking up and down as it's moving in and out of its stroke. But because of the way the pistons are on this steam engine, those piston rods need to be running perfectly parallel to the bore. They can't have that rocking action going on. The crosshead basically converts that rocking action into that linear motion. And it's just a kind of an intermediary piece here that does that. And we need to make sure that it is lined up where the center of the crosshead is on the center of this bore. Now to do that, I have a shaft that we've got in here that we're putting it on. The shaft has got a taper in it that matches the taper in the crosshead that we'll be putting in here. And if you look, I got some aluminum disc in here that I machined to fit the same size as the cylinder bore. That has basically a supporting that rod as it goes through here, and that rod is now lined up where everything is in proper position for us to be able to pour the Babbitt. All right, let's get in here and see if we can get this Babbitt poured. First thing I need to do is take the crosshead out. We'll get that old Babbitt melted off of it. We're gonna have to make some dams in there to kind of contain everything, and then we'll do our pour. So let's get at it and do it. So this is the crosshead piece. This is basically emulating the piston rod. This is not the actual piston rod, but it's got the same diameter and the same taper as the piston rod will have. And again, this right now is just kind of hanging from here. There's a gap all the way around this bottom block because we had to machine that out. See how it rocks? We need to get that line back up into the center. We get this poured out so that it is in the right position for us to be able to operate like we need to. This actual crosshead is made from cast steel. I'm pretty sure that's steel and not iron. I'd have to go back and check my blueprints on it, but the bottom part down here is Babbitt. Babbitt is a soft metal. It's a tin alloy. It contains some other metals in it as well. And it was used as a bearing material back in the day, mostly for shafts, for ball bearings, but it can be used in any kind of an application where you need a bearing surface. In this case, it's just sliding back and forth in this channel. And this tin soft metal, this Babbitt metal, is soft enough that it will move back and forth. Now, it will be running in oil. The bottom of this Stoker engine is flooded in oil, so there's basically a layer of oil down the bottom of this at all time. That oil will lubricate that area down there, and it actually makes a pretty good bearing surface. A lot of old school machinery use Babbitt, and this is a case where you need a slide. Babbitt's a good choice, still being used today in many applications. All right, let's get this crosshead out of here. I have to tap it out. That taper is just enough that it's locked in place there. There we go. Pull that out. I'm going to slide that up a little bit and we're going to take and melt this Babbitt off the bottom, and you'll see what we got up underneath there in a minute. That's not, it's mostly steel in there. It's just got a little layer of Babbitt all the way around it. Let's go to the welding table. We'll heat that up and melt it off. Got the crosshead over here. Got a label to catch my Babbitt as we cut it off, or melt it off rather. And I got a torch here with a rosebud. I'm gonna fire this up. And we'll just apply heat in that Babbitt. You can see it's melting already. I don't know if you can see it or not, but it is. Babbitt melts at a fairly low temperature in the metals world, usually about 700-800 degrees. So we're going to melt it all out of there. The nice thing about it is we can reuse this. Once it's melted out, we can put it back in the ladle and melt it and recast it over in our stoker when we get ready. Probably have to add a little bit of Babbitt to it. Probably won't be quite enough for the whole pour, particularly since we made it a little bit larger than the original size. But I've got some Babbitt laying around here, no problem. I think we got it all melted off. I'll just set this to the side, let that cool down, and we got our Babbitt in here that we can turn around and reuse. Usually what I'll do is I'll skim the top and kind of get the trash and junk will float to the top. It's lighter than the metal, and we'll just pull that out of there. So the next thing I need to do is come up with some dams to kind of dam up the end of these pieces when we drop our block in there. We're going to pour the Babbitt on to keep the Babbitt from coming out. And I think I'm just going to use a block of steel that will fit across this, and we'll put some damming material in there just to make sure it's good. But I need to figure out what the length is. So I'm just going to use a set of calipers here, and we'll get the good measurement here. And it looks like we're at 3650, and the height on this needs to be about 1.595. So I need to come up with something that kind of fits that bill. Let me see what I can dig up, and we'll cut a couple pieces to go in there. So I have some I think it's inch and a half stock. I just cut some blocks that will fit right in there. And now that should contain that Babbitt, keep it from flowing out the ends. It is just a little bit high. I think what I might do is go over to the mill machine and just kind of mill those down where they'll be flush with the top rails here. And yeah, I think that's going to be the thing to do. So let me do a little figuring here on exactly how I want to do that. Tell you what, let me put this crosshead back in here just for a minute. All right, so we'll have that up there at some point. We'll have one back here in the back. We'll leave the appropriate size gap between them. And I think what I want to do is actually lay the rails that are going to go on the top in here so that the Babbitt will kind of conform to the top side of that, and I won't have to go in there and machine or mill that. It's going to be hard to do with this overhang. So let me just kind of see here. We kind of put these in here. Got these over to the mill machine. We're 1 3/4, 1.750. We're going to 1.5 7.5. I've got it set at 0 right now. Let's see here. There you go. Let's go up. We'll just do about 25 thou per pass. Take our time. And we'll just deck these down. I think we're where we need to be. All right, this is coming together. I'll have to position those the right distance. I have to measure the other one and see where it needs to be, but it's going to be somewhere close right in there. And then the final thing I'm going to do is I'm going to go ahead and bolt down these rails in here, and these will make sure that we are capturing that Babbitt up underneath the area that it needs to be. I'll put one on each side, bolt them down in the final configuration here. Let's see here. This goes in there like such. Oops, wrong way. Yeah, like this. There we go. So we'll bolt those down, and I will probably just put some damming material kind of in right here. That'll give me a little bit of a pouring basin that we can pour into, and we'll just kind of pour it until it comes up more or less flush with the bottom of these rails, and we should be at the proper height. And that should contain all our Babbitt. Hopefully, I will probably do it where I can pour on the front and the back, just in case it doesn't make a solid fill. We can come up here and add a little bit on the other side. But I'm liking it. I think this is going to work fine. I think this is going to work. All right, let me figure out what we need to do here to get the rest of this set up. I think what we will do is I'm going to take out the crosshead. We're just going to get some heat down into the bottom of this whole casting, and then we'll come in and kind of build it out. We'll get this part heated up, keep the casting hot, get it all good and hot. But I want the biggest mass is the casting itself. So I'm going to start by just preheating that, and then we'll kind of build it out and get it where it needs to be. We're going to be working with it kind of hot, but I think it'll be all right. Y'all ready to do a Babbitt pour? I'm going to be honest with you. I'm a little nervous about this one. This has got to be just right. And there's a lot of mass in here and a lot of area for that Babbitt to have to flow. We're going to have to get this really good and hot to so it doesn't freeze up too fast. All right, let's see what we can do. All right, I got my Babbitt over here stewing on the pot. Just got it in the big ladle that we're going to use to pour it with, and we got it on a camp stove. The big cake down in the bottom was what we melted off of the originals. This up on the top is just a little bit of extra Babbitt that I had that was melted out of a previous project. And we're just going to mix it in there with it so to make sure that we have plenty of material, because I do know that area that we're pouring is a little bit larger than the original one, so we're going to need a little bit extra material. That should be more than enough to get the job done. We're going to let this cook and get over here and start putting some preheat into the casting to get it ready to pour. I got a big rosebud tip here on my torch, and we're just going to come in here and start heating up this casting. A lot of mass here. It's going to take a lot of heat, so this is going to take a little while. I'll be back here in a little bit. I'm not going to make you guys watch all this, but we've got to get this preheated up to, I don't know, 300-400 degrees probably. I want to make sure it's getting hot, and then we'll start assembling the parts and get that heated, and then we'll do our Babbitt pour. I'm shooting this with an infrared thermometer, and we're about 325 degrees. We'll just call it somewhere in there. It's running around that a little bit. Let's start kind of building this thing out. We're not through heating, but we've kind of got a preheat in the bottom anyway. So I'm going to put my dams in here. Get that one up front. Let's get our crosshead put in. Okay, that's in there and kind of centered up. Put our back dam in. I need to get a measurement off the other one to see what that gap needs to be. All right, these blocks need to be 7 3/8 inches apart. That's about right there. I want to kind of make sure I got this centered up in there pretty well. Very good. Now I want to put more heat in here. Get all that good and preheated as well. All right, we're up at about 400 degrees in there on most of this, so I'm going to go ahead and finish assembling that, and then we're going to give it another round of heat. And looks like our Babbitt is about melted over here, so about the time we get through preheating, we probably will be ready for our pour. So let me get these bolted in here. These cross slide guides. I can't get those tightened up. Main thing I want to do is keep the Babbitt out of those journals there, or those holes. So I think we've succeeded there. I'm going to take some damming material here, and I'm just going to put a kind of a glob in here, and this is going to just create a pouring basin so that I can pour the Babbitt and not worry about it running out the back. I can just kind of shoot for this little opening right here, and I am going to put one on the other side as well, although I'm hoping I can only going to have to pour from one side. See what kind of temperature we're at. The casting is around 300. That's about 500 inside here. 400. I think we're good. Let me check my Babbitt over here. See if it's ready to pour. I think we're going to give it a shot here, guys. Coming in with the ladle. And I'm just going to pour right down that little hole. And I got Babbitt coming up the other side. I think it's a success. All right. All we can do now is let it cool down. So we're going to do just that. I'm going to turn the cameras off, and it's going to be several hours before we pull this thing apart. This has had plenty of time to cool down. It's completely cool to the touch. And let's go ahead and start. See if we can get this thing taken out. Start by pulling out this damming material. And then we'll take off this top plate. I don't know how much trouble this is going to be to get out of here. I hope it doesn't bite me too hard. That one there is tight. I just put the threads in far enough there, just make sure no Babbitt ran down into them. Pull these out, and that worked beautifully, just kind of keeping that Babbitt from coming up too high. That's at just the perfect height. Now, let's see about getting these end blocks out. That is going to be a little bit more of a challenge. Let me see what I can do here. Let's see if we can knock that back a little bit. Oh yeah. Good deal. I'm using a lead hammer here. Shouldn't cause any problems. There we go. That block is out. See if we can get the front block out. It's coming right out now. Now I got a brass drift here, and I'm just going to knock that out, hopefully, that taper out. And then we should be able to just lift this thing up. I say lift it up, probably have to pry it up, but we'll get it out. There we go. Haha. I like it. That came out easier than I thought it was going to. Man, look at that. Beautifully poured block of Babbitt around there. Molded right to size. So we will do some scraping and get that fitted, but I think we got a very successful pour there. Let's take a closer look at it. I am, like I said, extremely happy with that. That, man, that just turned out beautiful. Couldn't ask for better. Everything just flowed in there really nice. We had plenty of heat in there, evidently. The Babbitt flowed in just like it needed to. You know, went a little bit higher above the surface than what we probably needed to there. I will cut these off. I will probably leave that little channel back there in the back. You know, that's just going to be kind of rubbing on the inside of those crosshead or those guides on the top. It's not going to hurt anything. It'll be blocked in down here anyway. Now, this is all going to have to be scraped so that it'll, you know, have just enough clearance to be able to run. It's too tight right now. We need to have a little bit of oil clearance in there, so we will do some scraping on this. I'm going to do that a little bit later on, but that it will be the game plan there to kind of get it scraped in to where it runs real good. So honestly, this far exceeded my expectations. I don't know, it seems like first time you do anything, it gives you trouble, but this turned out beautiful. I'm extremely happy with that. Well, guys, that worked great. Yeah, like I said, I'm actually surprised that I was, you know, not that I doubted my setup or anything like that, but it's just anytime you do anything like this, you just don't ever know how it's going to go the first time, and we nailed it. I mean, particularly getting enough heat and getting a good solid pour in there. That was my biggest concern. You know, some of this area around here with that, you know, you got that casting on the inside that everything kind of sticks to, but it's fairly thin, and we did a pour in one place, and having to pour and get it to flow all the way to the other side without freezing. You know, we had plenty of heat in there, evidently, that allowed us to do that. So that was my biggest concern, that we would get a partial fill. But like I said, it worked out great. So I'm very happy with that. So we got this one done, need to get the other side done. I was planning on going ahead and getting both of these done at the same time, but here's my situation. I'm almost out of gas in my settling tank. Don't have enough to do another heat to do this one here. I've got the Arnfest South event coming up this weekend, and guys, I'm just gonna be totally tied up with that event, and I've got to go get my tanks filled up. We're actually doing a brazing demo out at that event. I got to go get my tanks filled up for that. But it's going to be after Arnfest before we get a chance to pour the other side. And yeah, we'll probably do another video on it just because. I mean, you know, you've seen the process, but who knows if it'll go as well the second time around. Yeah, hopefully it does. But anyway, there you go. Happy with the results. And happy with where this project is moving along. That's the biggest thing. So guys, with that, for today, that's a wrap. As always, thanks for watching. Please subscribe if you haven't already. That really helps out a lot, as so does hitting that like button and giving me a thumbs up. Those help out a bunch. Leave the comments down below. That helps out as well. And the biggest way you can help out is helping out through PayPal, Patreon, and YouTube memberships. That helps out financially with making these videos. This is my full-time job now, making videos for you guys and working in the shop, but it seems like I spend more time making the videos than I do working in the shop. So anyway, if you can help out there, great. It's greatly appreciated. With that, we're going to get out of here. We'll catch you on the next video again. As always, thanks for watching.